Hello everyone and welcome back to my channel, Tech Tutor. Today I'm going to talk about Amazon SQS and how you can get started quickly using Spring Boot. There's dependencies in Spring Boot that you can use. It makes it much simpler to connect and listen to these Amazon SQS queues. And so basically I can get you up and started in around 20 minutes today. And it kind of takes away the daunting thought of how do I do listeners, or do I have to constantly poll or whatever. Spring has made this easy for you. I'm going to show you how they do it, and just go ahead and take a look at the code right now. In order to get the basic configuration set up, you will want to create a class to configure the Spring beans required for listening to queues. So let's go ahead and take a look at the SQS configuration class that I created. At the top of this class, you will see the Amazon SQS bean. So here I am wiring it up so that way it will use the localhost and 9324 port, as well as assigning a region of Elastic MQ. I'm doing this so that way it will point to the Docker image fake SQS that we're using, and this is the location of where it's going to be. If you're just going to actually connect to a real Amazon SQS queue, you can actually simplify this, and you can take away this part right here and just do Amazon SQS async client builder.standard.build. What will happen is that Spring will automatically pick up the environment variables with your AWS client and secret, the access ID and secret, and then it will connect to your Amazon account and automatically figure out where the queue is and the URL for connecting to your SQS queues. So I'll go ahead and I'll put that back. Furthermore, let's go ahead and take a quick look at the Docker Compose file so that way you're seeing where I'm picking up on this localhost 9324 and Elastic MQ. So I've created this Docker Compose file. We're going to use this to stand up the SQS fake system so that way you don't have to connect to an actual AWS account and spend real money. This will help you go ahead and get started, write the boilerplate code to be able to have a listener and publish to queues. So the name of the image that I am using is called S12v/ElasticMQ, and the ports are 9324. So inside of the container, that is the port that it is listening to and publishing from. And we want to also expose outside of the container for 9324. So you're just kind of connecting from inside the container to outside of the container, so that way the Spring app can talk to it. Lastly, this volumes portion right here, if you look at the notes on the website where I have pulled this container from, which I'll put a link in the description, there's actually a little bit of talk about this in the GitHub. Basically, there is an Elastic MQ config file you can create, and this will help you set the names of the queues in this fake SQS environment so that way the queues exist. Otherwise, if you wanted to test this, you could actually write code that will always generate the queues if they don't exist. Or usually if you're connected to an actual AWS account, you're probably going to create the queues manually inside the Amazon account and set different permissions, different settings for dead letter queues, etc. So let's take a quick look at this Elastic MQ config file that I created. So if you go over here, you're going to see some boilerplate code that I basically took from the GitHub example. And then down here where it says queues, you're going to want to put the name of all of the queues that you want to simulate. I would suggest that if you're going to actually hook this up to a real Amazon account, you want these queue names to match the same names as the queues in your Amazon account. That way it's just less to change, and that way when you end up creating your YAMLs, if you're doing a local YAML, it can match whatever your QA environment is and so forth. Now let's go back to our SQS configuration class. So let's talk about the next part of it. So we have another bean that we've created, and this is the queue message handler. And Spring is expecting this class in order to implement the listeners. As you can see, you have to wire up the Amazon SQS bean, which is what we created up here above. So this is basically how the queue message handler has access to the Amazon account, how it will end up being able to read and publish to the queues. And then you also, for our example, will want to create a message converter. What this will allow you to do is actually change the incoming JSON string into an object. This will allow you to deserialize the incoming message string into a Java object. As you can see, there's also a comment here that I have added, and this was suggested by the Spring documentation because AWS messages do not contain a MIME type header, so they suggest setting the strict content type match to false, because otherwise it could fail if it's not indicating to the listener that it is of type application JSON. And then the rest of this code is setting that argument resolver, which we have added as part of the message converter, and then creating the queue message handler from the queue message handler factory, which again, we had input the Amazon SQS bean into. Next, you will want to create a thread pool task executor that this can be used by your listener container. So I've set it as a core pool size of 10, a max pool size of 10. You can play around with this as needed, but for our example, this is just what I've decided to do. And you're going to add this thread pool task executor into your final bean, which is the simple message listener container. Lastly, you will want to add all the above configurations into your simple message listener container. This is so that way your listeners can actually pull messages from the queues. You have to pass it the Amazon SQS bean, the queue message handler. You can set different settings. So for instance, this one I'm setting it to pull up to 10 messages at a time. And then you also want to add that thread pool task executor so it has multiple threads to pull all these messages in at the same time and not have to pull them in one at a time. Now that you've provided Spring everything it needs to begin listening for messages, you will want to set up a component to listen for your queues. Let's take a look at how I did that in the sample listener component. So in this class, you're going to utilize this SQS listener annotation. As you can see, I've provided property paths here. This is so that way it's more dynamic. You can just put the name of the queue here, but if you want to change this out per environment or again, just make it more flexible for on-the-fly changes, this is what I would suggest doing. And then additionally, there's a deletion policy you can set. I'm setting it to always delete. You can set it to delete only on success or other configurations. If you click here and drill down into this, you can see that there's always, never, no redrive, or on success. Again, what this will do is it'll either always delete the message after it tries to read it, or again, if there's on success, it will only delete it if it's succeeded. You also could configure a dead letter queue, so things could go to the dead letter queue, but this is up to you. For simplicity, we're just going to say that anytime it gets the message, no matter what happens, let's delete it from the queue. And in my example here, I've only got 2 queues that I'm listening to, and I'm just trying to showcase 2 different ways that you can be listening to queues. So you can make it to where you're only listening for a string, and so when it comes off the Amazon SQS queue, it'll just be a string of the message. Or you can utilize that Jackson converter that we added, so that way it'll automatically convert it to that message object that I've created, which I'll show in just a minute. So it'll end up deserializing it from a JSON string into this message object, and then you can actually go ahead and access that message object within your listener without having to use the object mapper to change it in the method itself from a string to that message object. So let's just take a quick look. So my sample message object just has a string message body, and we're going to showcase that using Postman in just a few minutes. As you can see, I've also added some logging statements in here. I'm doing that just so that way when I do publish a message to the queue and it is read from the queue, you will see the information coming off the queue and the message being written in our log statement, just to show you that this listener is processing it, and then when this listener is processing a message off the queue. So again, this is queue.firstQueue because we're taking a property value to set the queue name, and this is queue.secondQueue. Additionally, this is all coming from the queue configuration. So I have first queue, second queue, and when you do this, basically Spring allows you to do a camel case, or I could have done a hyphen name. They both will end up going to the same thing, and this is all derived from my application YAML. So as you can see here, there's first dash queue or second queue. This is what I was saying, is you have the flexibility. They both actually end up becoming the same thing because Spring will either expect a hyphen or a camel case and end up turning it back into a hyphen, so it ends up reading it the same way, and that's why it works. However, the one thing is that when you do it this way, where you have the property name, you do have to match it, so it has to be hyphen or camel case. But what I'm really getting at here is that the queue configuration will turn it back into camel case, or again, you could have done hyphen. Before I forget, let's go take a quick look at the POM file. So in this POM file, you can see that I'm using the Spring Framework boot parent module, and this is what I'm going to use to drive the versions of the other dependencies. We're going to use Spring Cloud version Hoxton.sr9. Additionally, you're going to want to use Spring Boot Starter Web in order for you to run a web server locally. And here's the important part: to be able to access all of these Amazon AWS messaging classes, you're going to want to include Spring Cloud AWS messaging. As I said, that parent POM is managing the version, so if I control hover over this, you could see that it is automatically assigning the version of this dependency, which is coming from 2.2.5 release. As I was showing earlier, I am using Lombok. Spring Boot Starter Test is in here, but I'm not actually using it. And then down here, you can see that the Spring Cloud dependencies, which again is that AWS dependency, the version for that is being managed by this dependency management right here, which the Spring Cloud version was being set above. And so again, that is where everything is coming from. So let's go ahead and close that. Now let's take a look at the queue service that I created. I have created a generic message method. This one will take a string, it is the name of the queue, and an object message. And then we're going to use the object mapper that Spring automatically creates. We can configure this mapper if we wanted to. And then I'm going to be using required args constructor, which comes from Lombok, to wire this in. Otherwise, you could have done auto wired if you wanted. And we also need to wire in our Amazon SQS async bean. So the first thing we're going to do is we're going to convert this object message into a string using our object mapper. I'm going to log the message that is being written as well as the queue that is being written to. And as I've noted here, if you're logged into a real Amazon account and you're not faking the Amazon SQS, so when you actually code this, you'll probably want to have some way to switch back and forth and not have to hard code localhost in, but just for the example, that is how it looks right here. But when you're connected to a real Amazon SQS account, you don't need to specify the URL here. You could just specify the queue name and Spring will automatically derive the URL that it needs to publish it from because of all the connections it's doing and all the code that the open source community of Spring has created just to help you out. So it becomes a lot more simple if you're connected to a real AWS account. So then additionally, you also need to pass in a string. That is why we converted our object message into a string to publish to the queue. And then I'm just returning the send message result, so that way when we do publish to this, we can just see the example of what Amazon tells us back. And our fake SQS Docker image tells us a very similar example. It basically tries to mock what Amazon would show us, so that way you can get an idea of what this would look like. Lastly, let's look at the test controller that I created. So this controller that I have created, I'm using this to publish messages to the queue. So for my first example here, I'm just going to publish to the first queue, which I was having the listener listen only for a string. So we are expecting a string to come in. We're going to then say, grab that first queue from the configuration and pass that string message to that send SQS message method that I showed. And then second controller is used for passing a message object, which I showed this earlier. We're going to just pass that object directly over to that same method, and we're going to publish that object to the second queue. And because we're making sure that that message object will meet the criteria of this object structure, otherwise it would fail when it tried to deserialize this into the controller, we know that it will succeed when we go to listen to the second queue and expect a message object to come onto that queue. All right, let's go ahead and show you how you can spin up this Docker image. So I'm just going to go back to the Docker Compose YAML, just again showing that we're pulling the S12v/elasticmq image down, and we're going to run that on the 9324 port, and again use that config file. So an easy way to do this is let's go ahead and right click on our project here, and then we're going to say open in terminal. That will pull up again that path C code SQS, because that's where I've placed this project. And then it's as simple as docker-compose up-d. Now you won't see it here because I've already downloaded that image, but for you, when this is your first time, you're gonna see it say that it's downloading this image so that way it can run it. But now it is running, and then to show that it is running, you can do docker ps. That'll show that this container is running on 9324, and this is the name of it. And additionally, let's go ahead and start our Spring application so that way we can publish to this queue and also listen to it. So you're gonna go ahead and click the run button. I already have it up here because I've run it. Otherwise for you, you can just right click this application class and click run. It'll do the same thing. Now you see that I am running the application and it's running on port 8080. So let's go ahead and open Postman and publish to our controller. So again, just to remind you of what we've got, the test controller here has a /first under /test and a /second under /test. So let's go ahead and pull up Postman so that way we can publish to both of these APIs. As you can see, I've already set this up, so you're gonna need to publish to localhost 8080. That path that I said is test, and then your first API is under first, your second one is under second. They're both going to require a post. And so the first one requires a string, which I'm just going to provide that string as test message. We'll go ahead and send that one. And then you can see that the Docker image that we downloaded is simulating that AWS response. It's saying that it was a 200 HTTP status and that the message was received with other message information here coming from the queue if we were to publish to actual AWS. And then let's go ahead and also publish our second message, which it is expecting that object that I created where message body is the variable name and it is a string, and so we're going to just go ahead and publish test message as the value of message body as well. And we'll go ahead and click send. Again, that's also 200 from our controller, and again, it's simulating the response that you would see from the Amazon SQS queue. So let's go ahead and close this and go back and look at our Spring application now. As you can see in the logs here, it said from our queue service impl. Let's go to that class right now. So the queue service impl now says writing message, test message to Q1. So that's coming right from this point here. Remember, that's because I published to the first controller and that will write to Q1. And then it says that the message it wrote to Q1 was test message. And then you can now see that the sample listener class received that message, which was a string, and it said received a message on the first queue, test message. The same thing for the second one, writing message, and then that JSON string message body to Q2. And so we'll go back to the controller here, but it actually was a message object, so it's serialized and deserialized properly. So deserialization of that JSON string into message object worked, and then it passed it to that send SQS message method, and then the listener was able to, again, deserialize it off the queue back into a message object successfully, and then we went ahead and logged that we received it, and you can see that it is logging that message object here with the body of test message under message body. So that's it. Basically, you now have a simple setup to get your start for SQS listeners and publishing to SQS queues. You can expand on this. Obviously, there's more settings that I didn't elaborate on, and this is just a simple startup to get you up and running quickly. You can continue to expand on this, make it more flexible, perform more settings, but it is a great way to get started without having to pay a dime to actually run real SQS queues, even though they're not that expensive. But this will allow you to write all of your code without having to actually set up any real SQS queues in Amazon first, so you can start moving quickly, and then when you're ready to start actually setting up real SQS queues, you'll have all your code ready. Thank you for watching this video. I hope that you like it, and if you have any questions or comments, please let me know in the comments below. Please like and subscribe for this video. And if you want to see any specific content, if you'd like me to elaborate further on this or any other topics, please let me know. I will happily make more videos on anything that you want to hear about. Hopefully this was helpful for you and helps you get quickly started with Amazon SQS.